Finished up doing the calibrations and such, just waiting for the camera to cool down enough to start doing science with it. Which I guess it's probably Stefan sending the email to the image take text, huh?
Yeah, well, I'm not sure who's hosting. If we get permission to share screen, I can show what we're doing at the end of these calibrations.
Guess it's me. Let's see.
Ah,
Uh, let's just make you go.
yeah, thank you.
Cool.
Yeah, I think that's the last flat field done then. What's the temperature? Let's have a look. Oh, nearly there.
Getting close. Yes, I don't know
Just
exactly what the
the
issue
what? I think
was.
it's just down here, the temperature at the bottom.
Yeah, it sounded like the camera or some of the tech stuff that they're dealing with supposed to be in a vacuum and it wasn't for an amount of time, and the air heated up a little bit in there, so they reestablished a vacuum and poured a bunch of liquid nitrogen in, and yeah, now it's cooling down. When we first started off, it was about freezing, and then it went down to like minus 60 in like 30 minutes. And over the past like maybe another 30-ish minutes, it's gone down another 30 degrees. Uh, and then about 10 minutes after that, it's gone down another like 5 degrees. It's like an exponential thing. So it's going to cool down more slowly, but still on the right track. I'm trying to get it down to minus 105, but we're at minus 102 right now.
Looks like we're clear to take blue flats. I'm guessing the biases. We haven't done the biases yet, have we? But I guess we're better to wait a bit longer for blue biases. Um,
I'm gonna go hop back in the other call because I guess they are there, but maybe they didn't get my email and drag the
Yeah.
121 readout room to us.
Yeah.
I'll be right back.
We've got the people who are actually at the telescope solving this problem for us.
yeah, I think Paul might have been away from the computer when we said they were changing Zoom rooms.
Yeah. Yeah, because he's just responding there in
Yeah, just seeing, yeah.
the terminal. That's pretty funny.
Uh, I'd hold off for a minute is to in case Paul joins, just to check whether we can do the biases as well or not. Just because I guess it'd be easier to do them in the same order on both red and blue.
Biases go by pretty quick, in my opinion. So I guess worst case we could just take the biases again a little bit later.
Yeah, true. So you can go ahead with the biases or
Yeah, I think go ahead with them.
yeah.
Worst case, we'll put a note in. Yeah, we can talk about this a little bit. So in the calibration stage right now, there are a couple things we do. The exposure that you can see up on the top of the screen is an arc lamp exposure. Um, yeah, and that's so that we know pretty much where the different wavelengths are. So we have different lamps on right now. Let's say, or for that one, it was a mercury, cadmium, and helium, I think, are the bright lines that we usually see. And we use that to figure out exactly where each peak is and figure out what the bluest and reddest wavelengths are on the blue and red cameras and make sure they overlap. The biases are basically 0-second pictures on the cameras, and those are used to get an idea of when nothing else is happening, what the camera's kind of intrinsic properties are. So like, let's say sometimes the very far left side of the camera gets a little saturated compared to the far right side. And so that bias will pick it up and we take a bunch of them just so we know exactly what the camera is like. And kind of similar for the flats as well. We point the telescope at or actually, I think we point some mirrors inside at something called a super blue light. And that's a light that's just very generally bright. And we use that bright light to get an idea of when we're pointed at something with kind of a uniform brightness, what does the camera do? And that gives us an idea later on during the science and reduction stage of what we should subtract away from the telescope. Yeah. So like as the telescope or as the camera gets a little bit warmer as it's taking images, we can subtract away the right amount of heat from that and get the proper images for our science. And yeah, since kind of we brought up a little bit earlier, the vacuum being broken and the camera getting a little bit hot, we were discussing whether we should take the biases now or maybe a little bit later. And yeah, that's just if it's a little bit warmer, then the molecules of air and atoms and such are going just a little bit faster and they're jostling a little bit more. So it could kind of impart on the camera and mean that there are slightly elevated levels of electrons when maybe there wouldn't otherwise be. But worst case scenario, at the very end of the night, we just take some more biases because they go bright pretty quickly, and should be fine. Other targets. Yeah, I actually have a question there in chat about how this will affect our pointing and stuff. We target two main things for this project, one being variable stars in Andromeda, and the other being transients that are just all over the place, really. And tonight, Andromeda is going to be up pretty much all night, and it's kind of close to zenith, not close to zenith. It's maybe 45 degrees. I actually don't know how high up in altitude it is, but it's fairly high. So we are missing a little bit of time on our uh, galaxy of interest, but it was going to happen. So yeah, we'll miss maybe. It's pretty dark out already, so we're missing maybe the first hour, maybe 2 hours of observations. That'll equate to maybe 3 or 4 targets. And yeah, that's just hoping that tomorrow night we'll have more observations available. I do think like a rain and cloud system's kind of pushing into the area, so that might be a little problematic. Um, but yeah, we'll miss a couple targets. It's not the end of the world, but it is a little unfortunate. Um, but the remainder of the night won't really be affected. We're mostly going to be pointing at things that seem to have gotten really bright in a faraway galaxy and hoping to see what made it get bright.
Alrighty, so yeah, that is done, isn't it? Switch back to dome flats. Open for
Readout room.
that's the way I forgot. Okay, do your first test one.
And the current image you can see is actually the bias that I mentioned as well. So it's a zero setting exposure, and you can see that the left-hand side was a little bit darker than the right-hand side. So there's something that we're going to have to account for when we're doing our science. And that's the dome flat. So this is what a relatively uniform brightness thing looks like. And you can see the peak counts are around 22,000. Is that right?
Yeah, 22,000. Yeah.
Cool. Yeah, that should be fine. We are looking for them to be below a certain number to make sure that the camera doesn't oversaturate when we're doing our science. Wait. Hang on. Dome flat, super blue 25. Air position 4 is right. This is 25 seconds. Yeah, I think we're okay. It's kind of low on counts, but I think that's okay. Yeah. So Andromeda is at about 63 degrees altitude right now. So pretty high up. And it'll be there for a bit. It'll actually get higher until about um,
It peaks a little before 11:30, about 10:30. 10:30 looks
yeah,
like it peaks.
yeah, that's what I'm
Yeah.
seeing too.
Unfortunately, I don't know if we'll be able to get Monica's transient though, and she had asked us, or I guess to look at the star. I think it might be a little too low by the
Mm.
time we get on,
Oh, was it
but
something
well,
for early in the night?
it pretty much peaks right when the sun goes down, so
Mm.
we might have a chance to get it right when we start.
Okay. Yeah, that might one. I guess that might be our first target, and then we'll do our standards, and then go on with M31.
I think we should hit the standards first, and then real quick, and
Well,
then we can go on
yeah, I
to
guess the
Monica's
standards would be
target.
good.
The other thing is it's really faint, so it might not be possible to observe it if it's too low of an air mass.
Yeah,
I
yeah,
think it was like a 20 meg or something, or like so right at the very edge.
yeah. That plus being close to the horizon is not ideal.
No, not at all. So
Maybe tomorrow, if we can observe tomorrow.
yeah,
It's like on one hand, I like that rain happens, but on the other, it kind of ruins observations. Okay, I'm gonna step away for a little bit. I'll have my laptop still on so I can hear, but yeah.
Yeah, no worries.
Cool.
Oh, that's good. Now opening up.
With that, oh, something changes, let you know.
Okay, yeah, it's just in taking a few more blue flats when opening, pointing, and focusing the telescope. Oh, sorry, biases. Yeah. Okie doke.
Cool. Yeah. Yeah, just saw that now too. Now
Yeah, closer to the exposure, that was it. Is it worth saving these, do you think? Or
what was that?
is it worth saving these extra biases? Ah,
Yeah.
oh, yes, yeah. Okay, fair enough. Um, yeah, yeah, flat lamp is off. Okey doke. Okay. Yeah, we're at the right temperature now. So close, slow, zero, yep. Save. I'll do another 10 just so it's the same set as the previous ones.
Is the shutter looks like it's closed. Or never mind.
Yeah, it's
Ignore me.
closed. Yeah.
Um, was the flat lamp on while those were happening?
It's off. I'd all
Okay.
checked it's off. Yeah.
Yeah, I just saw the message in the thing, but we're chilling. Cool.
Oh yeah, yeah. Well, that's a good question. I've got it in the chat. How can you tell if mass is being transferred from one companion star to another? Unfortunately, I don't think I'm the best person to answer that. It's not exactly my field. I'm sort of new to this area. Um,
It varies. I'm not by any means a master in this field either, but from the research that I've done, there can be a few different effects. Um, it kind of depends on the gravitational attraction. Yeah. Characters in accretion disks falling inwards towards the star and generates heat due to friction. Accretion disks are a sign of mass transfer. Outbursts. Yeah, basically that. But yeah, the idea is there's going to be like a stream of matter between this donor star and the accepting star. Um, it can either form a disk if I think it always forms a disk around the star that's kind of accreting it, because it's going to be more gravitationally bound towards like the equator as opposed to the poles usually. So it kind of collects in a little bit of a disk around the star. Depending on how large the donor star is, sometimes if it's like in the red giant phase, for example, and it's like really, really big and ballooned, and the donor star is nearby, then the like tiny stream of matter going towards the donor can be really big or really small, or it can just kind of form what's called a common envelope. And then they just kind of it's less of a stream and more like they're sharing their outer atmospheres. There's mass transfer going on there. And that'll happen until sometimes the accepting star, the one that's taking in the mass, will reach a certain threshold point. If it's like a white dwarf, for example, where fusion can start up again on the surface and it'll flash in a helium flash usually. Heavier stars like neutron stars also have thresholds where they'll burn different elements and pop off a little bit. Um, but yeah, it's mostly in their spectra. You can usually see ionized gas in the accretion stream because you can kind of think of the material piling up in this bulge around the equator. And if it's a little bit higher density there and the material has been falling from, they're called like Lagrange points between the two stars, it'll have gained a lot of kinetic energy as it's falling down towards the center of gravity. And as it gets that kinetic energy, I don't know if you can hear my cat going off in the background. It's very funny. But anyway, they will get a bunch of energy, get a little hotter, and they'll be more likely to emit energy via their electronic transitions. Um, yeah. So it'll usually be emitting like hydrogen and other transitions in the accretion streams. That's another way to find them.
yes, I guess now we're just waiting for the telescope team to confirm they're all focused and everything's
Mhm.
working correctly. Yeah.
I think so, yeah. I don't think Paul's updated otherwise, but yeah, I think the telescope techs basically are focusing the telescope to make sure everything looks good on their end. Because yeah, we've already spent some time focusing the camera, but now they need to focus the telescope to make sure that everything looks good when they're getting the light to our camera.
Oh, yeah. Thank you. Yeah. Double checking we've done all calibration. It looks like it.
Biases, flats.
I'll just get the target entry wind up, set to go for when we're ready.
Start off with our standards. Oh, yeah, you can actually see them focusing the telescope now on that other one.
Oh, yeah, yeah.
Yeah, this is a object chosen by the telescope tech to make sure everything looks nice and sharp.
Can you guys hear me?
Yeah, we can hear you.
Okay, great. Seeing as one, I'm ready for your first target.
Great, thanks very much.
Very good seeing.
Yeah, I'll send, yeah, that's the right one. Sending coordinates to POCO.
Okay, got them.
Was it a 0.5 or a 2? It's a 2 slit we use, isn't it?
Yeah.
Yeah,
Yeah, I think it's 2 for these.
yeah.
We do 0.5 for the arcs. So they
Oh,
have,
yeah.
nice sharp lines.
And then a lot of times for the non-standards, you'll need, or those dimmer targets, you'll need to close the slit.
Yeah.
Yeah. We'll sometimes make the slit really small so that we can line up the target with the slit and then close it back up again. Or open it, my bad.
Oh shoot, maybe I should create a real quick finder chart for Monica's target, because that thing is really dim. And I guess we do have time to get it, especially if the seeing is super good tonight.
Yeah, it seems pretty good to me.
We were also pretty good last month on hitting all of our M31 targets, so I think
Okay, I'm guiding. It's all yours.
Great, thank you. We'll only be here for a minute or two, so. Yeah.
Right now, we're taking a spectrum of a star that is pretty well known, at least amongst people who take spectra. And we're going to use this star spectrum to somewhat define the other stars that we see. More like defining the wavelength range and the response across the detector and such.
Is this the right coordinates file? Because there's only, I don't think this is it?
What's its name?
no, that is somebody else's
Yeah, it's the
star list.
Philippencos.
Ah.
So it just kind of worked out that they had the same
Yeah.
standards. Well, it's
Uh,
the Filippenko group. That makes sense to me. Any file.
uh, there we are, yeah.
Top, go up a bit. Another one.
Ooh.
The directory is in the Filippenko right now. So you want to go there.
Yeah. Thank you.
Mm-hmm. Raja.
Too far.
Variant. T-list.
Two.
Yeah, try the version 2 one. Okay. Hopefully those are the right chords. Let me just double check. So for 28.
That's like the standard, yeah.
Yeah.
21, 51, 20. Yeah, that looks right.
Their standard is 11, 31.4, 1805, 34.2. Cool. Yeah. I do think there are some on that target list that are a little wrong, but I think it's like one. Yeah, that one.
Oh, that one. Yeah, I remember that one.
41 instead of one.
Yeah.
Tend to be pretty obvious mistakes, but do keep your eye out for that. I need to fix that.
Yeah, we're ready to change targets, please.
Okay, moving. I still have the old address.
Oh, sorry, yeah. I've
No
not
worries.
pressed it properly. That should now work.
Okay, we're on our way.
There we are.
Okay, you can begin.
Great, thank you. And again, we're only here for a minute or two.
Okay, for the next target, I put the finder chart in the Slack chat in case we need it, because it will be very faint.
Yeah, I probably just want to send that to well, I guess we actually want to see if the coordinates are even pointable.
Okay, ready to change again, please. Sent to Poco.
Yeah.
This will probably be kind of tough target to resolve. Do you think we'll be able to point to these coords for amount of time?
Oh yeah, because they're for 50 minutes, aren't they?
It should
Yeah.
be good. It should be pretty high up in the sky.
Oh, cool.
Yeah. So at about 60 degrees.
Yeah, that's plenty high.
But it is also at 19.8 magnitude. So it is right at the edge.
Yeah. Probably just gonna want to email the finder chart to the MH techs.
Will do.
Double checking I've not typed 10,000, not 1,000, because that would be a very long exposure.
Three different things.
Yeah, I can narrow the slit as well if that helps.
Probably want to lower the slit as well. Want to look for this guy.
Narrow the slit there.
You might lose guider copy. Give me a few seconds and we can
Yeah, no
restart.
worries.
field.
Yeah, that's a good question from the chat. Are any of these targets Hayashi variables?
Very. Is it like a variable star that's on the Hayashi track, I imagine?
I'm not sure.
That's my guess. Not that we know of. We are analyzing a subset of stars that are unclassified though. So a few of those will be on the roster for tonight, and they very well could be on the Hayashi track. Um, or cool. Yeah, if we were to see any Hayashi variables tonight, it would probably be some of the largest, bluest stars. Um, but it is totally possible.
As you said, this was a pretty faint target, so that's why it's tricky getting the slit directly on it.
Yeah.
Let's check it did reduce. Yeah, it's at 0.5.
Yeah, I think the slit's on like where the rectangle is, that green rectangle. I think that's a triangle that we're seeing. I don't know though. I don't think so, actually. Because that triangle looks different than the one we're looking at.
Yeah.
Because it should be pretty consistent orientation. Um, bright star. Centered on the bottom left.
Maybe we should try this target again tomorrow and see if Monica can be online for it.
Fair, fair. I guess my worry is
I
tomorrow clouds might come in.
Oh, true.
We've got a storm system approaching California right now from the north.
Yeah. I mean, it's also hard because I'm pretty sure it's like part of an extended object too.
Hmm.
So,
You
yeah,
could ping Monica and see if she's able to join to help, I guess.
take one first spectra and just see what we get too, because
Yeah, true. True.
Did we observe both the standards on both the sides, on the blue and the red side?
Yeah, we were able to. Those were our first two targets. We're trying to point at a object that Monica requested right now, but it's in a pretty crowded field.
it's very faint.
Yeah.
Could also ping her, go to an M31 target, and do that first, and then come back. Since it's not setting really quickly,
Hmm.
it'll be above 1.3 air mass for another. Oh wait, that's right. It is already 8 o'clock there. I guess
Yeah.
another hour or two. But I mean, it's setting really slowly. It'll still be above 1.5 air mass until midnight.
Okay. Yeah, I think 1.5 air mass is probably the limit for us.
The absolute limit, especially for
Yeah.
something this faint.
Yeah.
So maybe we just switch to an M31 target and ping Monica and see if she can be on to help us resolve the target.
Maybe. It also seems like he's on the phone. Like the deck is. This might
Yeah,
be
yeah.
something else going on.
That's not a good sign.
I think I'll have to head out soon as well. But I'll be back around midnight, I imagine.
Sorry for the delay, guys. We're taking care of a computer problem right now. It's going to be a couple minutes.
Oh, cool. Good to know. Thank
Yeah,
you.
no worries.
I'll take a computer problem over a technical problem any day.
Yep. Having said that, and I was observing it, the INT on the Palmer during my PhD. The telescope computer stopped talking to the telescope. So the computer said it was, well, yeah, it was tracking a target, the dome had moved, but we opened the little window to look into the room and the telescope was still parked, it hadn't moved.
Oh no.
So these things do happen.
Yeah.
Well, we can see stars in this instance, so it's hopefully not too bad.
Yeah. It not look. I'm not seeing anything. It's interesting that the Poco is generally in the very like in the right spot.
Hmm.
The REN deck there seems right, but I'm not seeing it. There we go.